In this video, we will talk about the scheduling algorithms. So, what is scheduling? Well, let's take an example. For example, you have two apples, and suddenly five customers are willing to buy those two apples. Then, for whom you will give these apples? So it maybe depends. For example, he may who came the first, he will give those apples to him, or who has more number of apples. For example, one who wants to buy both apples, he may give to him, or one who is very loyal to him, or very most frequent customer he may be. So it depends upon the algorithm what he use. So similarly, for a computer or that memory system, CPU also had many requests of the process, so you need to accept one and need to start one process. So it also uses some scheduling algorithms. Let's see what scheduling algorithms those use. So before discuss about the scheduling algorithms in detail, let's start a separation or classification of the algorithms or scheduling algorithms. There are two type of scheduling algorithms. One is primitive scheduling, another one is non-primitive scheduling. Let's take an example. Primitive scheduling. For example, if you are giving a speech on a stage, suddenly a chief guest has a immediate meeting, he wants to leave, so he just want to address at currently, so you immediately stops your speech and gives the stage over him. After he completes, you again come back and completes your speech. So this type of scheduling is nothing but a primitive scheduling. That means you start and leave, and someone maybe start and he may be leave, and afterwards you start or you may be leave. So starting, ending, so you leave and complete the job at any time. So such type of scheduling is nothing but a primitive scheduling. Then what is about non-primitive scheduling? Let's after the monthly test or that maybe surprise test, if the teacher wants to correct the papers in front of the students, then he correct the one of the papers, then immediately another person came, so please correct my paper. Then the teacher will replies that, wait, after I completion this paper I will check on your paper. So once if he started, he needs to complete the paper, then only he will goes for the next paper. In such type of algorithm, we use the non-primitive scheduling algorithms. So let's talk some more differences about those primitive and non-primitive scheduling. Yeah, so as I said earlier, so interrupt is possible in the primitive scheduling. So someone maybe stops you, which has a higher priority, but in the non-primitive scheduling there is no such type of interrupts. Once you start, you need to complete the job, then only you need to go for the new process. Yeah. Next, starvation. So what is mean by starvation? Starvation means suffers a lot. Is there if any is there any chance of a process starvation in the primitive scheduling? Yes, there is a chance of starvation in the primitive scheduling. For example, if higher priority process is comes in a regular intervals of time, then lower priority process will never get executed, so it may be starved. Okay, then is the starvation is possible in non-primitive scheduling because there is no some priorities. Yes, there may be the no priorities, but if you start with a process which has a higher burst time, that may be I didn't discuss about the burst time, no? So which takes a very long time. For example, you have very big truck and backside there is a small truck, so in order to travel this, it may take 5 seconds, but small one may take only 1 second, but even though it need to wait for the 5 seconds. So in such cases, the small burst times or small time which you use may starve for a lot of time. Okay, is there overhead is possible? Before discuss about the overhead, we need to talk about the, what do you say, context switching. So what is a context switching? For example, let us take A, B and C. Let us take three process are there. First you start with the process A. After some time, you schedule this, you preempt this and start a new process to the B, and after some time you preempt this and again gives back the control to the A. After some time you give back control to the C, and gives back control to the C. So in this way, so you giving the, you are preempting a process and giving the, allowing the other process to do the work. But in order to shift from one process to another process, it may take some time. For example, it may take 2 milliseconds or 1 millisecond. So this type of scheduling is nothing but this type of switching is nothing but a context switching. So because of, if more number of context switching are there, it is very difficult and it takes a lot of time. So this type of scenario is all said to be a overhead because it is very hectic. So this problem is arise only in the preemptive scheduling, and in non-preemptive scheduling there is no such type of overheads, because once you started you need to complete it and then go for the next. So the more number of context switching is not takes place in the in the preemptive scheduling. So there is no overhead. So due to all these overheads, the cost is very high, but here cost is very low. Let's take some examples. Those examples are round robin, SRTF, preemptive priority. These are all primitive schedulings. Let's discuss one by one in the next videos. And non-preemptive scheduling algorithms. So those are nothing but FCFS, SJF. FCFS means the first come first serve. SJF means shortest job first.